morning, students. In the last session, I defined what a function was and I introduced the various terminologies involved in function, namely a domain, a codomain, a range. And I do also remember that I gave you some examples of a domain, a range and a codomain. Okay? In today's session, we will see what are the various types of a function. Say, I have classified the types of a function under two headings. This is to make it easier for you to learn the definitions of the various function types. There's no differentiation, but still then, to make it more clearer and to make it an easy learning, I am going to define the various function types based on the domain and the codomain. You see, there are, say, 5 types of functions: one-to-one, many-to-one, into, onto, one-to-one and onto functions. The one-to-one and many-to-one, I will be defining it based on the domain. The into and onto, I will be defining it based on the codomain. And one-to-one and onto are combinations of both the domain and the codomain. Right? A one-to-one function might otherwise be called an injection. A one-to-one function is otherwise called an injection. An onto function is called a surjection. The one-to-one and onto function is called the bijection. The combination of the one-to-one and onto. Okay? So let's start defining the one-to-one and many-to-one based on the domain. I will define the various types of the functions with some examples also, starting with the first one, which is nothing but the one-to-one function. According to this function, just look at this definition. A function h, which is a mapping from a non-empty set x to a non-empty set y, is called a one-to-one function if for every distinct element of x there is a distinct image in y. Okay, now I'll show you an example for this. Okay, just look at this example. We have two non-empty sets, namely G and H. In the set G, I have written something. Okay, and as you know, these are some babies of some animals: gosling, pup, kitten and kid. And the set H has the elements, namely dog, goat, cow, horse, goose and cat. So we are going to show a relation between G to H. Now what is the relation that we are going to see? Is baby off. Is baby off. I will show you the relation, or I'll show you the correspondence between the set G and H by means of the arrow diagram. Shall we show the relationship between the set G and H? So gosling, okay, is related to whom by this, under this function, is baby off. Whose baby is gosling? It's nothing but goose. Pup, whose baby is it? It is the dog. Kitten, kitten is matched with cat. Kid, kid is matched with goat. So from this example, what do you understand? Distinct elements of the set G. The G set can be called the domain also. So distinct elements of set G is mapped with distinct elements of set H. Set H here is the codomain. So I am defining the one-to-one relation by means of based on the domain. So you see that every element in the domain has got an image in the codomain. So it is a function. Still more, every element in the domain is mapped with distinct elements in the codomain, and that is why it is called a one-to-one function. Moving on to the second definition of the many-to-one function. As the name indicates, you see that there are many elements in the domain which are mapped to a single element in the codomain. So how do we define it? A function f which has a mapping from A to B is called a many-to-one function if, here starts the condition, if two or more elements of the domain, which is nothing but the A set, have the same image in B, which is nothing but the codomain. I'll show you an example for this. Look at this real-time example for a many-to-one function. We have two sets A and B. Okay. In set A, you find something like the games, names of some games, cricket, hockey, tennis, and so. And in set B, I have written some numerals, and these numerals represent the number of players who are going to play the game. Okay. So F is a mapping from A to B. Let's see how we can show this mapping. Okay, shall we do the mapping between A and B? See, B, once again I would like to tell you what are these numerals represent. These numerals represent the number of members present in a team. Okay. So, tennis specifically I have taken it as doubles. So, how will we do the mapping? Cricket, how many members are there in a team? 11. Likewise, in hockey also we have 11. What are the games we have? 11. Football also we have 11 members. In tennis, I consider doubles, right? So, in a team, how many members will be present? 2 members will be present. Likewise, in kabaddi, you have 12 members. Okay. Now, this example depicts the many-to-one, say, function. Say, every element in the domain has, say, unique element in the codomain, and that is why it is a function. Still more, two or more elements in the domain have the same image in the codomain, and that is why we call this function as many-to-one function. I like to clarify what this numeral 1 and 6 represents. 1 represents the member present in the chess game, and 6 represents the number of members present in a team in a volleyball game. Okay.